Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a closer look at lvalue references. I kind of thought I could do what have been in effect 3 videos in practice in one video, but I've realised this is so complicated that it's better to spread it out over a few videos. So this is the code from the last tutorial. I've just deleted the stuff that I typed in the last tutorial below this line here. Now, in C++ 98, we have references, of course, which in C++ 11, we now call specifically lvalue references because C++ 11 introduces rvalue references. So an lvalue reference is a normal kind of reference. If we have a reference to our test object, for example, test reference test1, let's maybe call this, let's put R for reference there. So this is a normal reference, and we can bind it. We can bind it to an L value. We can only bind these L value references, the old type of reference, to L values, with one caveat, which I'll explain in a minute. So we can set that equal to test1, and that's no problem. It's just normal code that would work fine, even in C++ 98. So if we try to bind a L value reference to an R value, we find that we can't do it. If I say test reference, let's call this reference test2 equals, and remember that the return values of functions are R values. That is, they're temporary values which don't have a name. We can't take the address of them, and that tells us that they are R values, not L values. So if I try to bind this to get test, it's not going to work. Let's try to build this and we'll get a compilation error. So that doesn't work. But we can actually make it work. What we can do is we can make this const, because const lvalue references can in fact bind to R values. So if we build this now, it does actually work. What actually happens here is that we get the lifetime of the R value returned from the function, in this case, gets extended. So as long as this reference exists, this object that is returned from getTest will continue to exist. It's extended beyond the lifetime that it would normally have. Normally it will be a temporary variable, which, as we saw in the previous tutorial, would be destroyed pretty quickly as soon as it had served its purpose. But here it's going to hang around until we hit this closing bracket and the reference goes out of scope. It has to be like this if you think about it, because if you look at a copy constructor, then the copy constructor always has a const lvalue reference parameter to it. And that means that with copy constructors we can do things like this. Let's say test2, and we're going to pass in an object of type test. So I'm just calling the parameterized version of the constructor here, and the reason I'm doing that is because if I try to call a no parameter constructor in this situation, then this particular version of this compiler gives me an error involving it thinks that this looks like a function unless there's some parameter in there, and that's why I created that parameterized constructor earlier on. But this works fine, and it works because const lvalue references can bind to R values, because this is a R value. It's not got a name. We haven't given it a name. We can't take the address of it, so it's an R value, and we're passing it into the copy constructor of this object, and this object, of course, is an L value. So that's all I really want to say in this tutorial. I wanted to go over that before we go on to R value references. And if there's anything here that surprised you or that you're not used to, then I definitely recommend typing this out for yourself. Try creating some L value references, both mutable and const. Mutable just means they're not const. And check that you can't bind mutable R value references to R values, but you can bind const L value references to R values. It's worth kind of verifying that, because what I found in learning this after years of doing C++ 98 and not really thinking about this in depth, to be honest, what I found was that it only became clear when I typed stuff out. So that's always my advice. And in the next tutorial, we'll take a look at R value references, I hope, in C++ 11. So until next time, happy coding.